Paris. It says 8 hours 27 minutes currently, but we need to change this time. So let's change this to JavaScript. Let's return an object saying hours minutes. We already found out that it's 20 hours 19 minutes, right? 20 hours 19 minutes and Paris. Okay. Hello all. Looks like we are live. Let's share a link. So our goal is to reach bronze without reading the problem statement. Let's start. Okay. There are 4 participants from our organization. Let's start. Getting started. Okay, no spoilers. We are not going to read the problem statement, which means you are not going to read any tutorials also. We are in mood 2 right now. And how are we going to find the problem statement without actually reading the problem statement? Is using the play button. Let's play. 9 people watching my stream. Thank you guys. Okay, there are some trees in the map. Okay. So let's try a game between the boss and boss, because right now we don't have anything written in our code. So let's play a proper game between the boss versus boss. Okay, both the boss got 72 points and 2 trees. So it looks like they are using their stars to get the trees. So see here, so there are some stars here for each player, and they are using the stars. They are collecting it. Okay, they are first collecting the stars. Each player is collecting 6 stars. So maybe each star gives 3 points, I guess. So if you count the number of stars each player is getting in the first turn, it is actually in the first turn you are getting 6 stars. Okay, all the red stars goes to the first player and all the blue stars goes to the red player. Sorry, the second player. Okay, we already figured out half of the problem statement, I guess. And from the turn 2, the trees start to disappear. Alright, so let's see what's the input and output format in this. In the first turn, both of them print complete 10 and complete 16. Okay. So here it says the boss is scoring 22 points from a tree. On cell 10. Okay, there are indexes for that in the map actually. So for each cell has an index. This is 25 and this is 31. Where is 0? 0 is probably in the center. Okay, this is 0, 1, 2, 3, 4, 5, 6. And this one is, where is 7? The indexes are actually weird. Okay, the first innermost, this one is 0, this will be 1, starts from 1 and ends at 6, and then again starts at 7 and ends at 18, and starts at 19 in the last circle and it ends at 36. So there are 36 cells in the map. So complete 12 will, let's see what complete 12 does. So our 12 should be somewhere over here, right? Yeah, 12 is here. And what is this? So red player says complete 10. And blue player says complete 16. So both of them disappear and each of them gets 22 points. Okay. So on this one reduces to 16. Maybe to cut a tree reduce 2 points or something like that. Reduce 2 stars. Next time both the bosses are getting 16 points by doing a complete action on 20 and 29, and they're also waiting. There are 2 squirrels here. Maybe we are controlling the squirrels. Okay, let's. So here we are getting the number of possible actions. Let's change the language to C++. So getting the cells information, each one has its index richness, says if the cell is usable. 0 means unusable. Index of neighboring cells. Okay, I like the graph kind of structure here. In each turn we are getting the day, so there are 24 days actually. This is an useful information. Usually in other games we used to have a counter for each of the game loop. Right now they are giving it in the input, which is easier to code. Nutrients, the base score you gain from the next complete action. Okay, if you use complete, we will get this many points. Okay, then it means we have to collect the nutrients as quickly as possible, I guess. Your sun points, your current score. Opponent sun points, opponent score. There are 2 suns. Okay, suns, I think probably the star that was showing here. So this is probably the sun points that is given initially. 18, right? Number of trees index, and this is my tree, or this is a dormant tree. Okay, number of possible actions, all legal actions. Okay, how about we print the first possible action? So we have a lot of possible ways to play this game, and let's just play the first possible action. Let's see what happens. And let's try to print the first possible action. Okay, I need to change my player. So 7 people are watching the stream. So what rank are you guys in? Have you guys started? How is it going? Are you guys in bronze already? Okay, we got 6 points. Let's see what happened. Okay, we printed wait. Actually, wait is also a valid action. And in the second turn we didn't print anything. Okay, oh shit, I think I'm probably mistaken here. So first time it would be true. Let's also print the action and see what are the possible actions. Okay, the first possible action is wait, so that's why we are printing wait. and then we do nothing all the turns. So we should never print wait. Let's print the last possible action maybe. So for last possible action we don't need any of this. It will just replace last action. We're getting some points. We won the game actually. What happened? We printed complete 3. We got 24 points. We printed complete 21. Okay. Maybe the points for each tree is different. Okay, I see there now. So this tree is worth 24 points and this tree is worth only 20 points. So the central trees have the most points actually. So we need to get the trees with most points, but let's test this in arena for now. Let's change the song.
Eight out of 10 women who tried wheat creams liked it. It's suitable
Advertisements.
and gives you smoother,
Okay, we are losing some games.
Just wheat it.
That means people are cutting the right trees. Okay, let's change our code so that we cut the trees with maximum points. So I have to start with something. I have to start with a proper code. So I'll use my starter code and convert the existing code to my starter code. So this is the input part. Which comes in my initialize. This input will help us for debugging purposes. So we are storing it in a string. Okay, logs input is currently true, so it will be useful for debugging purposes. So once we initialize, we need to start the particular turn, which looks something like this. We don't need this scene ignore stuff. Okay. Okay. So we need to know the points of each tree. So in a game state, you can have something like map of int comma int 3 points. So given an index of the tree, we know the points of the tree. So at each turn, let's clear this, and whenever we read a tree, we know the points of the tree. 3 points of cell index. How do I know if the points of this? How do I know the point of this tree? Okay. Right now, it's given us nutrients. So each tree has a cell index, mine, dormant. What is the meaning of dormant? Not active. Okay. Size. So this is probably the size of the tree. Maybe we can sort by size. Bigger the tree, better the points, right? Let's try it. And I think let's try to get all our trees only. Let's not. I think that's, we can get that in number of possible actions. Okay, let's store that here. String possible actions. Start of the turn, clear this. Push all the possible actions. So we need to find the best solution. The solution is probably we need to look through all the possible actions. And then get the action with the best score, right? So to get the index of the cell, we can do something like this. String possible actions. 5. And the first string would be something like this. Action. So if action is complete, then this means we are cutting a tree and we need the index of the tree. So get the cell index. So we know the points of the tree also. We need to find the maximum points, right? Max size is initially -1 and the max cell is initially -1. So if max size is less than 3 points of the cell index, then our new max size would be 3 points of cell index, and our maximum cell would be cell index. And once we get the solution, we need to store it in the best solution. So in our solution class, we have only one possible move right now as our solution. And move is nothing but string and an integer, right? So we have a string move and integer cell index. So now that we have our move class ready, we need to go to nTurn function. So here, just have to print our move. Solution dot move and solution dot move index, which is cell index. This is what we print in a turn. So find the best move and we have to store it actually. So here the solution dot move would be complete. The solution's score would be cell index, right? Sorry, the solutions maximum cell. Let's try this. Okay, we haven't read all the input. We got 24 points in the turn 1 and in the turn 2 we didn't read all the inputs. Okay, let's see what happened. Now initialize, we are reading all the cells, number of cells, and in our start turn we are reading day, nutrients, sun score, opponent score, all the cell inputs. We are reading all the inputs. What are these empty lines? So the possible actions, okay, I think the new line character is not ignored because we have used get line, right? Okay, instead of get line, let's do scene action. Need to get an empty character here, I guess. Disqualified. Okay. Let's use scene. So the possible action is complete. We need to read the index. So here, when we are pushing the possible action, can have something like class possible action should be good. Cell index. This is basically the move class, right? So we can reuse the move class. We can have a vector of move. So we are adding all the possible actions to the vector. Three people watching the stream. Okay, there is some error in my code, is it? Let me compile it.
For he is limitless. For he is limitless. For he is limitless. Oh, who is he?
Class move is not declared here.
Rhetorical question, but they
Okay.
all know the answer. Keith Lee. Yeah, and I ain't playing around. Think you can stand up to me, but it's best you stay on the ground. Lay still and don't make a sound, cause I'm just getting started, boy, and yeah, I'm making them rounds.
Here actually.
Blood, sweat, and tears on that gridiron. I've been the greatest for years, and you just still trying. For he is limitless. For he is limitless. I'm at the top of my game, and you ain't close to that. I'm staring down at you, aiming, you think you close. In fact, it's quite the opposite. I'm miles ahead of you. Go back to boot camp and come face me with a better you. Cause I'm a legend, I could never going back down. And you're irrelevant, so I'ma turn my back now. I put my blood, sweat, and tears on that gridiron. I've been the greatest for years, and you just still trying. For he is limitless.
The type's already defined here actually.
Oh, who is he? Who's that champ I see? Rhetorical question, but they all know the
Okay, let's move this function below that actually. It should work.
And I ain't playing around. Think you can stand up to me, but it's best you stay on the ground. Lay still and don't make a sound, cause I'm just getting started, boy, and yeah, I'm making them rounds. I put my blood, sweat, and tears on that gridiron. I've been the greatest for years, and you just still trying. For he is limitless. For he is limitless. I'm at the
Okay.
top of my game, and you ain't close to that. I'm staring down at you, aiming, you think you close. In fact, it's quite the opposite. I'm miles ahead of you. Go back to boot camp and come.
You're already ranked 30 with printing the last possible move.
Never going back down.
So right now we are trying to print the maximum cell. Okay, we got enough points, but then in the last turn
And you just still trying.
we did something wrong. Instead of waiting, I think we probably printed complete -1. Okay, so if there are no possible moves,
Keith Lee.
then
And I ain't playing
should
around. Think you
probably
but it's best you stay on the ground.
the best move would be to wait, right? So
Make a sound, cause I'm just getting started, boy, and yeah, I'm making them rounds. I put my blood, sweat, and tears on that gridiron. I've been the greatest for years, and you just
so the cell is not -1. Our best move would be this. Otherwise, our best solution would be wait.
For he is limitless. I'm at the top of my game, and you ain't close to that. I'm staring down at you, aiming, you think you close. In fact, it's quite the opposite. I'm miles ahead of you. Go back to boot camp and come face me with a better you. Cause I'm a legend, I could never going back down. And you're irrelevant, so I'ma turn my back now. I put my blood, sweat, and tears on that gridiron. I've been the greatest for years, and you just still trying. For he is limitless. For he is limitless. Oh, who is he? Who's that champ I see? Rhetorical question, but they all know the answer. Keith Lee. Yeah, and I ain't playing around. Think you can stand up to me, but it's best you stay on the ground. Lay still and don't make a sound, cause I'm just getting started, boy, and yeah, I'm making them round. and you just still trying. For he is limitless. For he is limitless.
So right now we will choose the tree which is of maximum size and then print it, right? Okay, you're getting some junk value. Okay, we got into the wood one just by printing a valid move. Okay. Okay, let's try this in our wood one. Where does that number come from? What number, Murat? What number, Murat? Okay, here instead of trees we have some plants and our code is crashing. Okay. Grow. Okay, I was printing complete, so here this condition was wrong actually. This max cell is not equals -1 should be the condition, but I used best move cell index not equals -1. Okay, right now, so we got promoted just by printing a valid action. Now currently our code is crashing, so let's fix that first. Okay. So in our error stream, we get everything printed on the same line in the first term. So let's see what's happening. So in our initialize, we need to add a new line here for each cell. So once we read each cell, we get the particular terms input, which looks something like this. Okay, now we have many multiple possible actions. We can wait or grow. It looks like. What about the complete? Okay, maybe we can complete only after the plan becomes a tree, I guess. Okay. So as in wood 2 till now, Murat, so I didn't use any grow commands till now. So we just used complete command so far. Okay, we need to plant trees and grow trees. Okay, let's try how the boss is playing. So we are not supposed to read the problem statement, that's a challenge. We have to reach bronze without reading the problem statement. We already made it to wood 1, so we just are one level away from reaching our target. So let's play boss as boss, analyze the inputs. Okay, let's see what they are doing. Thank you for the follow, Murat. Okay, what's happening here? Okay, okay, looks like the grow command grows the tree size of the tree, I guess. So once the size is good enough, we can start to collect, I think. And each cell has some richness points associated with it. Okay. So whenever a tree grows, we try to collect the tree, and if there are no trees, then we have to try to grow a tree. I think that's the optimal approach here, so that we can grow trees quickly. And I'm not sure if I'm allowed to cut the tree of opponent, so let's try it and explore. Yeah, it's an interesting challenge, right? People keep trolling me that I'm asking doubts without reading the problem statement. Hi, not today. So the challenge is to reach bronze league without reading the problem statement. Okay, now let's try our code. I think it's currently crashing. Now we are getting the inputs properly. So these are the information about every cell. So we get the number of cells, and for each cell we get the index richness and the neighbor indexes. So each cell has 5 neighbors. So how are some cells having -1? Okay, which means it's a boundary of the graph, so it doesn't have any cell in that particular direction. And in the first turn we get the day. So in the first turn we get day 0. In the second turn okay, what is this actually? Is there an infinite loop in my code? Looks like so. Let's see what we are reading. I think the problem should be in the reading something. We have a loop here for the number of trees. So we are getting the tree input correctly. For the possible inputs, wait and grow. Okay, these are also we are getting properly. Or if the possible input is not equals wait, can just push the possible action. In our get best move, so we go through all the possible actions, and if the cell is maximum cell is not there, we are currently printing wait, and if there is a maximum cell, then we just complete the tree. And if there are no possible cells, then what we have to do is we have to grow the tree, right? So let's do that, and let's try to grow the tree which is already of a bigger size. I think that's one way to do it. So if there is a maximum cell, you can just return right here. Otherwise, we try to grow. So if there is a grow action and we find the maximum size, same way we need to find the maximum cell as well. Let's reuse the existing variables. So now we found the cell with the maximum size, and let's try to grow it. So it should look something like this. Right. We're already rank 678. We did nothing actually. Okay. Our code crashed. Let's see what actually happened. We did grow 11 and the opponent did grow 29. CG Prakash is growing a tree on cell 11. Okay, it just grew here. And the opponent grew at 29. Cool. So we grew a tree successfully. And in the second turn, we printed some junk value. Okay, it seems wait is the only possible action and we printed some junk value. Okay, let's see what happens in that case. Get best move. So let's see what will be there in the possible action. So this array size would be 0. Okay, these values are negative actually. And some possible actions are okay, I think the possible actions is not cleared every turn. It's cleared actually. Okay. Good night. try this challenge. This looks fun. So we are pushing the possible actions only if the action is not wait. So let's debug it. Maybe we can, this contest runs for 10 days, so there is enough time. Okay, number of possible actions is 0. Okay. So this is fine. So this loop will not run. So max L would be -1. This if will not run. So finally our best move should be move of wait, right? This one will store the move here. Okay, this is M actually. Small mistake. I think now it should work. Yeah, we have been alive for 25 turns. Let's see what happens. We got 22 points. £24 and we won it. Actually, I don't know what happened, but we beat the bot. And let's submit this and let's try to explore what happened. So in the first turn, we grew a tree. An opponent also grew a tree on 13. In the second turn, we both were waiting. Third turn, we both collected 5 sun points. So I think the sun points is collected automatically after every round, is it? Okay. In the next turn, we grew a tree on cell 35 and cell 21. We both were waiting. We both collected sun points. We grew trees again, waiting, sun points. Okay, we both are doing the same actions, but how did I get extra point? Maybe we collected a tree with more points, I guess. So in this step, I have collected 6 sun points and the opponent has collected only 5 sun points. Let's see what's happening in the battles. We are winning most of the games. Let's see our losing game and see what happens. Here our opponent got 42 points. We have 10 viewers now in the stream. I have no idea what I have done because I haven't even read the problem statement. And I just grow trees and complete trees randomly. And my logic currently looks something like this. So I go through all possible actions and I get the size of the tree in that particular cell and try to find the tree with maximum size and then try to complete it. If there are no such trees to complete, then I try to grow the tree. And again with the same condition with maximum size. So this is our current logic and seems to work so far. And in this particular case, let's try to open it.
Hello.
For he is limitless.
Okay. Let's go turn by turn. I'll click on right arrow. So in the first turn, we both got 4 sun points. So to grow a tree, I'm probably spending the sun points, I guess. So richness is 3 and 24 points. After growing it, both the trees become dormant. Okay, dormant trees means it hasn't grown completely, I guess. The next step, we get 5 extra sun points. Okay, 5 for we have 3 small trees and 1 size 2 tree. So in the first turn we had 4 small trees, so we got 4 sun points. Now we have 3 small trees and 1 medium sized tree, so we are getting 3 plus 2, which is 5 sun points. Okay, we are getting to understand the problem statement without actually reading the problem statement. So what is opponent doing? Why is the squirrel sleeping? And okay, it's like a wizard squirrel. Okay, we both are probably sleeping. Okay, the squirrel is actually sleeping. Wait is actually sleep. And there are some arrow marks here. 1 second, I'm sorry. Okay, so there are some arrow marks over here, and the arrow mark go in this direction. Maybe denotes alternate turns or something. So okay, in this step we got 24 points. Let's see how we got 24 points. It's because we grew a tree in the center of the map. Okay. And let's see what happens next. Okay, he's making a tree in the corner and he got 42 points, but I kept on sleeping. Why? I could have grew a tree, right? Let's send this game parameters to IDE.
I'm at the top of my game, and you ain't close to that. I'm staring down at you, aiming, you think you close. In fact, it's quite the opposite. I'm miles ahead of you. Go back to boot camp and come face me with a better you. Cause I'm a legend, I could never going back down. And you're irrelevant, so I'ma turn my back now. I put my blood, sweat, and tears on that gridiron. I've been the greatest for years, and you just still trying. For he is limitless. For he is limitless. Oh, who is he? Who's that champ I see? Rhetorical question, but they all know the answer. Keith
Okay.
Lee. Yeah, and I ain't
In the first turn, I am printing grow 3. Okay, I am printing grow 6 and opponent is printing grow 3.
lay still and don't make a sound, cause I'm just
And we both are waiting in the second turn.
them rounds. I put my blood, sweat, and tears on that gridiron.
Okay, in the third turn, he is growing a tree,
You just still
but I am printing weight.
for he is limitless.
But I can grow 3 trees, right? So I should have grown 3 instead of waiting. I have printed weight in error stream. Okay, there is only one possible move here. How did he grow 3 when the possible inputs were only grow 6, 24, 27 and 22? Okay, this is opponent's grow 3 and I printed grow 6. Okay, makes sense. So opponent plays first. Opponent plays weight. I play weight. Opponent again plays weight. I'm playing grow 24. Okay. Okay, I probably built opponent's tree maybe. And opponent actually cut it. Let's try to grow and collect our own trees. Maybe that should work. So here we have an isMine variable and if isMine is true, then the points would be the size of the tree, otherwise the points would be something like a negative points. So usually this tree would be picked only if the points is greater than the -1, right? Because here in the get best move, here we compare the max size with 3 points. So if it is -2, then the tree would be never be picked. So we'll just grow our own trees and complete our own trees, right? Let's try this one. Okay, again we got only 22 points. Let's see what happens. We grew a tree there. Okay, he built a tree in the center. Why did I build in the corner instead of building in the center? Okay, I built two trees. Instead of focusing on one tree, I grew two trees together. Because this one was dormant. In the second turn, I grew this one instead. Okay. So I'm trying to grow trees parallelly. So I'm waiting for a long time, I guess. The tree doesn't automatically grow anyway. So it's better to grow trees one by one, right? But still the trees come in the same order, so I should keep growing the same tree again and again. Instead I'm growing different trees in different turns just because the tree is dormant. Okay, let's try again. Okay, let's try different opponent, maybe the boss. As long as we are doing a valid action, I think we are fine. Against the boss, we lost again. He has 23 points and we have 22. Okay. What are we missing? I guess if there is a dormant tree, then just wait on the turn. If our tree is dormant, then just wait. Let's have a tree class. Class tree. And start turn. Here we get the information about the trees. Store it in the tree and use these. So here we have multiple trees. Mm, let's read the trees input. So let's grow a tree only when we don't have any other dormant trees. Okay, so for I less than trees, do I have a dormant tree? If trees of I okay, this tree is mine and trees of I is dormant. This is true and then break. So if I don't have a dormant tree, then try to grow a tree. Otherwise wait for the tree to grow and then complete it and then come back and grow this tree. I think this makes sense. Let's try this one. So what level are you guys in? What is the highest league right now? I think it's bronze. Looks like there are 1,000 people in Wood 1 trying to read the problem statement, and we are at rank 182 without even reading the problem statement. You save time if you don't read the problem statement. Okay, there is some compilation error. Let's fix it. You have to define this function below this class for this to work. Okay, compilation is fixed. I we saw there was a warning, I guess. Cell index unreferenced. Okay, we can remove this. Okay, now we grew a tree and we are waiting instead of building another tree. Okay, now we got a bigger tree. 22 points. We are there 3 trees already built. Okay, something still wrong. Okay, during first turn, so we are red player, right? We are actually blue, so we built this tree. And the second turn, we build this. Or did we build this? We could have built this one. There are no dormant trees, and the size is same for both of them. This is size 1 and this is size 2. So I should have built this tree because the size of this tree is 2. Am I getting the maximum tree? Let's remove 3 points. We don't need that anymore actually. So given an index, we need to find the tree in that index. Is the tree dot size. If tree dot index equals index, then matched tree would be t's of I. That's it. So we can use this get tree function right now. So let's get the tree at that particular index. The tree is mine and the tree is not dormant. Tree dot size is greater than the max size. And the max size would be tree size. Max cell would be possible actions of cell index. That's it. So we try to complete the tree with maximum size in this, and here we have to return. Actually, we have returned again. The move is grow, then get the tree at the particular index and get the size of the tree. And you can find the maximum cell. Okay, cool. At the same time, if you want to you can grow it only if the tree is not dormant. There are no dormant trees, then we get the tree with the maximum size. Let's play some song. Okay. Okay, we have already beaten the boss actually. We will be bronze soon. It's 76% completed. We were actually able to reach bronze without even reading the problem statement. See what happened in the replay. Our bot got crashed. Thank you, Murad. Okay, compilation error. We got only 8 points this time. Let's see what went wrong. We're probably not growing enough trees. Exactly. We're not growing any tree at all. We added is dormant condition and we stopped growing trees. So boss is growing a tree on cell 13. We are not growing anything. Let's see what happens. So do we have a dormant tree? So this tree is mine. If this is dormant, then this becomes dormant. Okay, then I think one of these trees is dormant, I guess. From the inputs, the last parameter is dormant. Looks like all trees are not dormant. Then let's print this. Suppose if this is false and it goes inside this and we have grow conditions, we need to get the tree as well. So let's print the tree size also. Possible growing tree. Cell index tree is mine. Tree dot size. Let's debug this. Okay, now So I don't have a dormant tree and everything is 0. Okay, my tree data is wrong actually. So I haven't pushed the tree, is it? Oh, I forgot to push the tree. Now it should work. Okay, I need to also handle an invalid tree. I think that shouldn't be a case. Okay, let's try this one. Okay, this time, okay, that's the output. So there is no dormant tree, so I'm growing a tree at cell 21. Which is correct, which is the first tree with the maximum size. So in the second step, I see a dormant tree. So I'm actually waiting. In the third turn, I do have a dormant tree. I don't see the dormant tree here actually. Everything is 0. How do I have a dormant tree as 1? Here I see many ones, which is fine. Index size, mine and dormant, right? Number of trees is 8. Okay. I think we need to have breakpoints. So let's try to debug this locally. This is turn initialization, turn 1, this should be turn 2. Should be turn 3. In turn 3 we should get dormant tree false. So let's have a breakpoint where we are pushing the tree. After pushing the tree,
working. He go act like he don't like it. You know I tell you the nicest. Nobody touch me in a
So in
ride.
turn 1,
Nobody takes me in a crisis.
let's watch trees.
You took my heart and my keys and my patience. You took my heart and my sleep for decoration.
We can just hover over this.
For you for foundation. All that I wanted from you was to give me something that I've never had, something that you never see, something that you've never been.
Okay, we need to read from the input file actually. Okay, now we have 8 trees with is mine true, dormant is false. Swatch trees. So in the second turn we'll get this. In the third turn, okay, the tree size keeps increasing. So in each first time its size is 8, second time 16, third time 24. We have to clear the trees after every turn. So you can just do trees.clear and it should resolve the problem. So this is how you debug locally. You need to remove the input share. How many percentage has it completed? Okay, 96. Will be bronze in no time. And let's try to submit our new code and we should be able to get in top of the bronze. Let's check the leaderboard and check our overall rank. Okay, currently a large number of people already reached bronze, more than 1000. Okay, let's try to get to top 500 in bronze without reading the problem statement. I have never read a single line in the problem statement all through the stream, and the goal of this stream is to get to bronze without reading the problem statement. Logan, welcome to the stream. Okay, now we started to beat the boss again. Let's check this replay. See if what we intended is actually happening. No, we are growing more than one tree at the same time. Grow the existing tree, don't build a new tree. Opponent is also doing the same mistake actually. So let's debug this again. So I don't have dormant tree, so I'm growing a tree at 12, which is of maximum size. Now I do have a dormant tree, so I just wait. I don't grow. In next turn, I don't have a dormant tree, so I'm growing at 30. But I could have just waited for the tree to be complete instead of growing this tree, right? The opponent is also doing the same mistake, which is okay. Our code is working as intended. Okay, we are getting promoted. Some seeds. Okay, plant new trees using the seed. This update we are allowed to read. We are not allowed to read the problem statement. That's it. Oh no, my replay is gone. I probably have to test my code against my own code right now. Why not reading the problem statement? That's a challenge. People always keep trolling me saying like I don't read the problem statements, so I wanted to show them that what I could do without reading the problem statement. Welcome to the stream, Ganesh. I think my code is crashing in the new league. Okay, talks, and after some time it crashes. There are some new changes in the input. Let's see what are the changes in the input. Okay, so we have a seed step. We can actually seed on a particular cell. I think it's better to seed on the index 0, right? So let's seed on the index 0 so that we get 24. The richness is very high in the green area, but there can be competition in the center index. So let's try to take some random index around this and plant it there. We will get the same 24 points anyway. So let's take index 5 maybe and try to plant a seed there. So there are no possible moves. Okay, seed is also a possible move. We are allowed to seed only on some specific cells. We cannot plant seed at random locations. Okay. So let's just plant a seed on the first location that is available. So if the possible move is seed, then just make the best move as this. And cell. Okay, on this possible index, and then just return. Now in our end turn, like the solution was complete. Okay, we don't need this. Let's see if we are able to plant a seed. Expected seed from 2. Okay, we have to print 2 indexes. Let's try to play a game between the boss and see what the boss is doing. Yeah, bronze, astrocyte. We reached bronze without reading the problem statement. Yeah, reading the problem statement is for kids. You didn't read either? Okay. Usually the statements are very long and it takes 2 hours to read the statements, and right now we are 2 hours into the stream and we have already reached bronze, so that's what you get. So now if you, like after the stream, if I go to read the problem statement, then it would be pretty easy. So as long as I have written a code that is scalable. So yeah, but you don't have to write any serious code, but it's better to have something like a scalable code structure with proper classes and functions, so that even after you read the problem statement, your code should scale accordingly. Instead of rewriting the entire thing. Skeleton code, okay, yeah, good then, good for you. Let's see what the boss is doing. Oh my god, lot of things are happening. Let's go slow then. So initial map looks like this. There is something called a shadow size. Richness is 0. Okay, then maybe we are not allowed to plant our trees there. So Ganesh, so this is a 2-player artificial intelligence game where you build a code that fights against the opponent. So what you see on the map is a game, and you probably win by getting more scores. Right now, so after the end of the game you see a screen like this. So one player got 59 points, another player got 34 points, and the first player won the game. There are some rules in this game which of course I didn't read because of the challenge. So without knowing what the actual game does, so this is the first day of the contest. This runs for 10 days. So people in coding game usually, whenever I ask doubt in the world chat somewhere here, hey, help me with this. What's the board dimensions? If I ask something like this, then people will troll like go read the problem statement. it's right there, but then if I go to look and read the problem statement, it will be very huge and it will be very difficult to look, and people keep trolling me. So I wanted to take it as a challenge, like you troll me whatever you want, I can do my best even without reading the problem statement. Now it's 37 tiles. Okay, who cares about the number of tiles when you have dynamic memory allocation? Just use an vector and you are safe. Reverse engineering the problem statement. Yeah, just print what are the other players printing, then try to guess what's the game. So right now in the Wood 2 league we had like already there will be trees in particular cells and we need to cut the trees. Whoever cuts more trees gets win the game. That's the level 1. In the level 2, which is Wood 1 league, where we can grow our own trees and then cut the trees. But the smaller plant would already be available, so we can grow the tree and then cut the tree. We cannot plant a tree, we cannot seed. So in this level 3, in the bronze league, they have brought a new rule saying we can also probably place seeds, which looks something like this, I guess, from the diagram. So let's click the play button and see what the bot is doing, and I'll just go one step at a time, clicking the right arrow in my keyboard so that it doesn't play the whole game. Okay, step 1, both are getting 2 sun points. Step 2, both are planting a seed, or the plant randomly drops some seed or something. We don't know what's happening here. And let's see what are the players printing in the second turn. Okay, they are printing seed 27-28. Okay, so this particular plant should drop a seed in a particular cell. I think maybe it should also be a neighbor, I guess. So we can take the seed from a plant and then plant somewhere nearby as well. I think that's the case here. That's what both the players are doing here. And this plant is idle currently. Maybe we can do only one plant at a time. Don't forget it spirals out from the center anti-clockwise. Yeah, that we have noticed. So here if we hover it, so it says index 0 and index 1 and there is a circle, and after 6 the 7 is not somewhere here or here, it's here in this. Let's consider this as the x-axis, from 7 to 18, and this will be 19, from 19 to 36. Yeah, this and all we figured it out in level 1 itself without even reading the problem statement. So now okay, at turn 3, okay, at turn 3 both the players are using the another plant and creating another seed, and there is some shadow here. Okay, shadow is I think based on the sun direction, I guess. Right now the sun is shining in this direction. Okay, I see the shadow now. So this arrow marks make sense now. So when the sun is shining in this direction, the shadow is in the right side of the plant. And when the sun is shining in this direction, then this becomes the shadow. So I think the sun is revolving from in the anti-clockwise direction. No, it again comes back clockwise, is it? Okay, yeah, it's anti-clockwise. Okay, yeah, the sun is anti-clockwise. You can see the arrows rotating. And tree height, I use the size of the tree right now to reach bronze league. So if I hover over here, you see the size of the tree. This one size is 2 and size is 2. Okay, now what happens to the seed? Okay, the seed, it's converted to a plant here. Let's see what the red player is printing. Red player is printing grow 28. Okay, to grow a seed we have to print grow 28. Same like growing a existing tree. So we can grow a seed or we can grow a tree, or maybe we can consider seed as a tree of size 0. That should be simpler as well. I don't know if there is any extra property for a seed which we can also handle using the size. If the size of the tree is 0, then we can assume it's a seed without having to introduce a new class called seed. We can use the existing structure for tree. So okay, now here the tree planted a seed in the center, so it doesn't have to be adjacent, it looks like. Blue player played a great move here, seed 36-1. So from the tree in 36 he planted a seed at 1. I think the optimal way to place a seed is placing it in the center, so that the richness value is high and we get a lot of points. Okay, let's see. So we get the seed location of the tree, I guess. So from seed we need to decide where we need to place the seed, right? So for this we can use an index which is very small, so that okay, let's go to tree and let's initialize the cell index to negative. And here get the cell which doesn't have a tree already. That's where we can place a tree. So less than, so it starts from 1, right? Starts from 1 and ends at 36. If so let's try to get the tree at this location. Get tree at itself. So if there is no tree here, the index wouldn't be -1. So it would be -1. In this case we can try to place a seed there. best location to drop seed. Would be I and then break. So let's drop our seed in this location. So let's introduce a target index in our move class. So in end turn, solutions move seed. Okay, see you Astro. So you will be able to seed now. Let's try this. Let's There are 6 streamers online right now. Let's check who are all streaming. Nice. We are at rank 3 in the number of streamers. Okay, our code got crashed. Let's see what's wrong. Has not provided any action in time. Okay, the opponent is playing seed 27-28 in the first turn, and I am playing seed 36-1. I'm trying to place the seed in the center of the screen. Say the tree on cell is too far from the cell. I cannot plant a seed there. Okay, maybe there is a range limit. Okay, if there is a range limit, then I need to use the neighbors of the tree, right? Maybe I need to start storing the neighbors. And maybe the distance from the cell to another cell, if it is less than 2, it should be possible, I guess. I haven't read the problem statement, but I have seen a replay where a seed was planted at a distance of 2. Is there any shortcut to find this? Okay, this is like 0, 1, 7 and 19. There is a pattern here. Yeah, plus 6, plus 12. So maybe this increases at the size of, okay, this one contains like 6 hexagons, and outside that we will have 12. And here probably we'll have 24. Let's sum this up. 1 plus 6 plus 12 plus 24, which is 43. Do we have 43 here? No, we have only 36. 1 plus 6 plus 12, and in the last round it starts from 19 and ends at 36. So it's like 18, I guess, in the last level, and we get 37 including the center cell, starting from 0 to 36. Okay, so this is the pattern we have here, and if we get if we have our current tree at 0, any of these cells, we can just plant it in the next index. Otherwise we can plant it in the previous index, right? Because that will definitely be adjacent. If we get 0, then just plant it in the 1. If we have 2, then plant it in the previous one, it should be adjacent. Yeah, I think that should work. Cannot too close to another tree. No, closer to the tree is possible actually. I saw a replay where also here see, like from 27 it's possible to plant a seed here closer, which is just distance of 1, right? This is possible. It cannot be too far. It can be too close, but it cannot be too far. So this idea we can just change it something like this. So if I equals, if my current tree, which is tree dot cell index, is a multiple of 6 plus 1, right? Should be 0, 1, 7 and 19. So in this case, just try to plant a tree next to this index. So we start from the current cell plus 1. So if you are at 0, we start from 1 and check which is the empty cell. Whichever is closer, we try to plant a tree there, starting from that index. till 36.
For he is limitless.
Otherwise,
For he is limitless.
you have to look in the reverse until 0.
For he is limitless. Oh, who is he? Who's that champ I see? Rhetorical question, but they all know the answer. Keith Lee. Yeah. And
So suppose we have a tree at 9, we check from 8, 7, 6.
still and don't make a sound, 'cause I'm just getting started.
Usually we will get it closer. This may not work, but usually in the first 2 cells we should be able to get. That's the idea here,
Greatest for years.
because if we go an index of 3, the distance would be very high.
For he is limitless.
This is not the ideal way to do it. We have to use the neighbors concept. We can do that later.
And you ain't close to that. I'm staring down at you, aiming. You think you close in fact. It's quite the opposite. I'm miles ahead of you.
13 is not there. 13 is not there.
You. 'Cause I'm a legend. I could never go and back down. And you're irrelevant, so I'm a
13 is somewhere here.
put my blood, sweat, and tears on
It's here.
red iron. I've been the greatest for years, and you just still trying. For he is limitless. For he is limitless.
Let's try this.
Who is he? Who's that champ I see? Rhetorical question, but they all know the answer. Keith Lee. Yeah, and I ain't playing around. Think you can stand up to me, but it's best you stay on the ground. Lay still and don't make a sound, 'cause I'm just getting started, boy, and yeah, I'm making them rounds. I put my blood, sweat, and tears on that gridiron. I've been the greatest for years, and you just still trying. For he is limitless.
Okay, our code gets crashed here.
I'm at the top of my game, and you ain't close to that. I'm staring down at you, aiming. You think you close in fact. It's
Opponent plays C27-28.
you. Go back to boot camp and come face me with a better you. 'Cause I'm a legend, I could never go and back down. And you're irrelevant, so I'ma turn my back now. I put my blood, sweat, and tears on that gridiron. I've been the greatest for years, and you just still
You're
trying.
probably not reading all the inputs.
For he is limitless.
Okay, here there are 5 possible moves.
Oh, who is he? Who's that champ?
Wait, seed, and what are these? What is 1900?
Yeah, and I ain't playing
I think something in the input is weird.
Lay still and don't make a sound, 'cause I'm just getting started, boy, and yeah, I'm making them rounds.
Maybe I have to read the problem statement if there is something changed in the input.
Been the greatest for years, and you just still trying.
How do I figure it out without using... Okay, it's possible if someone uses this debug information.
Down at you, aiming.
Boss is not printing any debug information,
The opposite, I'm miles ahead.
so we'll have to find another way.
Come face me with a better you. 'Cause I'm a legend, I could never go and back down. And you're irrelevant, so I'ma turn my back now. I put my blood, sweat, and tears on that gridiron. I've been the greatest for years, and you just still trying. For he is limitless.
Let's try to use getLine and then see what are the possible actions.
He is limitless. Oh, who is he? Who's that champ I see? Rhetorical question, but they all know the answer. Keith Lee. Yeah, and I ain't playing around. Think you can stand up to me, but it's best you stay on the ground. Lay still and don't make a sound, 'cause I'm just getting started, boy, and yeah, I'm making them rounds. I put my blood, sweat, this for years and you just still trying. For he is limitless. For he is limitless.
So in the default code it was there actually. Let's reset the code. Why is this printing twice? Get move is called twice. There are 5 possible moves. Wait, seed. Okay. The location where we need to plant the seed is also given in the input, so we cannot place a seed at random locations. Okay. Then that makes the problem simpler. You can just store it like we have a class action. We are using the move class, we can reuse it here again. So Okay, now we are storing the location of target index. Now in the get best move, can just plant a seed.
Oh yeah, look at it go. Roll out the barrel, feel it in your bones. Oh yeah, look at it go. Roll out the barrel, feel it in your bones. Oh yeah, look at it go. Roll out
Target index.
feel it in your bones. Oh yeah,
We don't need any of this.
roll out the barrel, feel it in your bones. Feel it in your bones. Feel it in your bones. Go, go, feel it in your bones. Go, go, now go, feel it in your bones. Go.
Okay, we have survived for 17 turns and we got 105 points. Let's first submit this in the arena and see what our bot is actually doing. This should probably take us to top 100. Let's see what our bot is playing. So we are currently blue player. So yeah, we are planting a seed. We are planting a seed there. We are growing a tree. We are getting more seeds. Okay, the tree probably chooses the best closest location to plant the tree automatically, and we get that in the possible actions as the input. So we don't have to find where we have to place the seed. We can just place it wherever it allows us to place it. So till now opponent hasn't grown a full tree yet. So as long as we are planting a lot of trees and we go closer to the center, we will be able to build more trees in the center which have a higher richness value. So as the game passes, we'll get a lot of points in the center of the map if we get there. So okay, how are we going to get into the center? That's the question. Okay, we got into the center. Opponent also got into the center. Opponent has 2 seeds in the center, but he hasn't cut a single tree. Okay, finally he cut a tree. Okay, maybe he is trying to expand the territory faster than cutting the trees. But it's not possible to get into the center without placing a tree in the tree, and the tree pops up the seed in the center. Okay, let's see how was the output. We are winning almost all the games. Okay, this should definitely take us to top 100 for sure. So without reading the problem statement, we are already getting closer to rank 100. We have 8 viewers. How are your bots doing, guys? Which league are you guys in? What rank are you guys in? Seriously, I have no idea what my bot is doing, but I just print some possible action and I'm here. I haven't even read the problem statement. But obviously, as the days pass by, today it's just the first day of the contest. Once the silver, gold and legend league opens, the competition will get tighter. And I will definitely have to read the problem statement after the stream. Where is Astrobytes? He's the one who always trolls me. So we lost 2 out of the first 14 games, which is a really good sign actually. Let's watch a match between Struct and QWERTY. See what the top guys are actually doing while the leaderboard is in progress. And let's understand what their strategy is. Are they going to the center quickly to get an advantage? Okay. Struck won the game by 11 points. And let's go to the middle of the game. Oh yeah, as I expected, they are capturing the center and keep growing trees in the center. So they fight for the center basically. So we can even output something to our squirrel for debugging purposes. Let's try to do that actually. Let's see if our squirrel shouts hello. This is a very important feature in our bot that we just added. Yeah, awesome. Hello. You can even shout like if you want to raid shout, if the opponent has more points than it, so we can like shout stop doing that or something like that. We can just print random quotes and swear at the opponent if we want. Okay, so our aim was to get to top 500, which we achieved. I think that's a good time to end the stream. It's been like 2 hours and 47 minutes. Everyone, thank you for joining the stream. I hope you had fun. see you all. Goodbye Ganesh, goodbye Astro. Goodbye all. Good night.